Welcome back to a new Marcus Maths video. Today we are resuming with our AP Calculus BC study, and today we're going to be looking over and analyzing continuity and all these discontinuities that occur when we are evaluating these limits and when we're just discussing continuity in general. This is a very important concept as it will tie in with some later ones in upcoming units, so it's important to pay attention with this video. Make sure to subscribe if you haven't already. We're going to be doing AP Calculus videos throughout the entire week over the next 5 days. We're going to be finishing Unit 1, Limits and Continuity. Well, let's go ahead and get started with this quiz. We have 6 questions, and our first one is discussing whether h is continuous at x equals 0. So, as we can see, we have a piecewise function, and it's very important to define what continuity is. Continuity is when we, first of all, h is defined at 0, and then second of all, our left-sided limits and our right-sided limits are equal to the value of which h of x is defined at. So let's say f of 1 is equal to 3. Well, that means if f of x is continuous at x equals 1, that means that the left-sided limit has to be equal to 3 and the right-sided limit also has to be equal to 3. And that's what we're going to be testing with questions such as these. First step, is h of x, is h of 0 defined in the function? When h is equal to 0, we will use this part as it's x is greater than or equal to 0. And we can see e to the power of 5 times 0. 5 times 0 is 0. E to the power of 0 is equal to 1. So we can see that h of 0 is indeed equal to 1. It is defined. That's our first step completed. Now we're going to look at our left-sided limit and our right-sided limit. So with our left-sided limit, as we approach 0 from the left, we can directly substitute 0 in for x. E to the power of 2 times 0 is 0. E to the power of 0 is 1. So the left-sided limit of h of x, so the limit, how we would notate this, is the limit of h of x as x approaches 0 from the left is equal to 1. As we could just directly substitute 0 into the left side of the piecewise function, we yielded 1. And when we directly substitute the same value in for the right side of the piecewise function, we also yield 1 as the answer. Since h of x is defined at 0 to equal 1, and both the left and right side limits are equal to 1, h is indeed continuous at x equals 0. We passed all those requirements for continuity. Okay. H is continuous for all x is greater than -7. We need to find h of 2. We can see here that x is not equal to 2 because when we substitute that in, we get 0 in our denominator and 0 in our numerator. We get indeterminate form. And if you remember from last video, last calculus video, when we have indeterminate form with square roots such as these, we use the conjugate method of simplifying. So we're going to multiply both the numerator and denominator of this fraction by the conjugate of the denominator. The conjugate of the denominator is the exact same thing, but instead of -3, we plus 3. So we're going to multiply h of x by the square root of x plus 7 plus 3, both on the numerator, both on the denominator and on the numerator. The reasons why we do this is because it will eliminate this discontinuity, as you will soon see. So when we multiply out our denominator, we have difference of squares, so we can just square both a and b. All right, x plus 7 squared is simply x plus 7. Well, square root of x plus 7 squared is x plus 7. And then 3 squared is 9. So that means our denominator is now x plus 7 minus 9, which simplifies to x minus 2. Denominator is x minus 2, while our numerator is x minus 2 in our first parentheses, and our second parentheses is what we multiply the numerator by. This square root of x plus 7 plus 3. As we can see here, we have x minus 2 on both the numerator and denominator. We can eliminate eliminate these factors, which eliminates a discontinuity at x is not equal to 2. So we can go ahead and directly substitute x equals 2 into our remaining function, the square root of x plus 7 plus 3. 2 plus 7 is 9, square root of 9 is 3, 3 plus 3 is 6, so h of 2 is equal to 6. on to our next question. Okay, we're looking at a graph here. Select all correct statements about f at x equals 4. Without even looking, we can take a look. The left-sided limit is equal to 1. The right-sided limit is equal to 1. But f is not defined, it's not defined at the same value for which the left and right-sided limits are equal to. It is defined that f of 4 is equal to negative 4, but it's not that same 1 value that we yielded with both our left and right-sided limits. So that means continuity is off the table. Let's go with each of our answer choices. Okay, the limit on both sides exists. That is true. The limit for the value exists. Remember, the limit for the value is when the left and right-sided one-sided limits are equal to each other. They're both equal to 1. So the limit of f of x as x approaches 4 does indeed exist. F is indeed defined at x equals 4, negative 4. However, since that value is not equal to the limit of f of x as x approaches 4, aka 1, it is not continuous. Okay? We're going to be analyzing for an infinite discontinuity. So we have 3 different types of discontinuities. We have a whole discontinuity. We have a jump discontinuity. Usually it occurs with piecewise functions. Let's say here, and then we just jump to over here. This would be a jump discontinuity. Then we have finally an infinite discontinuity. These are unremovable, and these come in the form of asymptotes. So an infinite discontinuity would be an asymptote, and we can see that this function h is going to asymptote twice at 2x values, at x value of negative 6 and at the x value of negative 2. We have 2 infinite discontinuities, as those are the 2 asymptotes of the function. And just so you guys know, we cannot remove those. We can remove our whole discontinuities. Very easy. Okay, over which intervals is g continuous? Remember, continuous is when left-sided, right-sided limit of the value exists, and the function is defined at that exact same value of which the limit exists at. As we can see here, that is not going to be the case when x is equal to negative 3, when x is equal to 0, remember we don't go off of y value, we go off x value, and when x is equal to positive 3. So we need to avoid those intervals. Let's take a look. A, from negative 2 to 0, since this interval includes 0. Remember, brackets include, parentheses exclude. That interval is not going to be continuous because x equals 0 is not continuous. Now, from 1 to 5, once again, x equals 3 lies on that interval, so that interval is also not continuous. None of the above is the correct answer with this question. Very important to understand the difference between brackets and parentheses. Alright, on to our last one for today. Which of the following functions is continuous at x equals negative 2? Remember, we're going to look at the 3 things. Left-sided limit, right-sided limit, and is the function defined at that value to the same value of which the limits are defined to? Let's start with h of x. Let's first find the value. H of negative 2, we're going to substitute that into the function. Negative 2 plus 1 is negative 1. The cube root of negative 1 is equal to negative 1. So it is indeed defined at that value. Alright, next we're going to find the left and the right-sided limits. Our left-sided limit, we are simply approaching from like negative 2.001, etc. And those values do indeed approach negative 1 as well. The limit of h of x as x approaches negative 2 from the left is equal to negative 1. And then if we're approaching negative 2 from the right, from these more positive values like a negative 1.999, they are also approach negative 1 from the right, since the left side and right side of limits are equal to the value of which h is defined at. H of x is continuous at x equals negative 2. Now let's try f of x. First, let's find the value, f of negative 2. F of negative 2 plus 1 is negative 1, and we cannot take the cube root of negative 1. Remember, it works when we have an odd index, does not work when we have an even index. We will get into non-real answers with our imaginary value I. Since the function is not defined at that value, the function cannot be continuous at x equals negative 2, which means that h of x, h is the only answer for this one. Okay, that was all with this question, analyzing these different continuities, discontinuities, and whether functions are continuous at the point. It's very important to understand this because we're going to introduce another factor, whether functions are differentiable, in later units. Definitely stay tuned for that and future videos going over quiz 5, 6, etc. until we get to our unit test soon enough. I will see you in those upcoming videos. Everybody, I wish you a good rest of your evening. Make sure to subscribe to the channel if you haven't already, and goodbye.